what we have here is this is where that 2-inch ram pump comes in. Now Glenn here is going to explain how this system is going to work.
Alright, when it comes in, it runs through our first filter, which is a 20 mil filter, which was going to pull out all your solids and everything else. From there, it runs into the inline chlorinator.
What does a chlorinator do?
It's what's introducing the chlorine into the water, allowing us to begin the flock process of basically it begins to disinfect the water along with building a flock, and it'll allow you to pull out a lot of your particles along with your impurities into your water.
Okay, so that takes out all the impurities and that kind of stuff.
It begins to build a flock, or basically this is a mixer basically.
Okay.
It's mixing all the chlorine into your water, which allows it to come into this tank.
Okay.
This is where your flock actually begins to happen. I'm using some of same terms that we use in the water industry as a water plant. So if you don't understand it, I'm sorry. I'll try to explain it the best I can.
Okay, so this is where the flocking process starts?
Basically, it comes in and it's shooting down.
Okay.
And there's a big tube coming in here.
Okay.
And it allows it to come back up. It basically builds a membrane, kind of, in a way. It basically, that chlorine builds a layer and allows to hold down a lot of your solids and impurities into your water.
Okay.
Allowing cleaner water to come up.
Now there's a clean out on this, is that correct?
Yeah, this is the clean out when we kick it all out.
Okay.
The cleaner water comes through. So basically anything that is water soluble is the only thing that's going to be allowed to come up. So it has to be lighter, or the really, really fine particles. That's the only thing that's going to be left coming out of this tank.
Okay.
And you can then it comes through this filter.
Now, well, I remember installing this filter, and oh my goodness.
And this is, if I remember right, a 0.5 membrane, which we will even go even smaller than that.
Now, this used to be a white.
And it'll come through, and this will pull out a lot of those really fine particles of mud and everything else that's in your water.
And any insect parts and all that
It's
got
already
through.
taken care of here.
Oh, okay.
All your insects and stuff should be stopped in here.
Okay.
I mean, all your big stuff's here. This is taking out your really fine, if you're...
really fine
just
silt
like if you
sand.
take a glass of water, a clean glass down to the pond, scoop water out and sit it down, or in a creek, and sit there. You'll see a bunch of really, really fine stuff settle.
Okay.
If it sits there for a week or two, that really fine stuff, that's what it's pulling out right here.
Okay.
Then it's running through this is a sand filter.
A sand filter. So that entire thing's filled with sand?
No. It's filled with layers. This has sand and different membranes in there.
Okay.
And it basically is acting the exact same way that an industrial sand filter that the city water plants are running.
Okay, let's get a shot of the
only difference is
here.
this is a one-use deal. Once this is burned up, it's done.
Okay, but we can recycle the container once this is used up. We can we can dump all that sand and stuff out, make like a compression tank with it, right?
Not that I know of, because once you break that seal, you're basically cutting that. That is an industrial seal.
Oh, and this is made of fiberglass.
That is a fiberglass tank.
Okay. So once this tank is used, what kind of lifespan does that have?
It's based off the flow.
Okay.
You have basically 1 million gallons of water is what this is going to be for. Or
whoa. That's a lot of water.
We will probably replace this every couple of years not because we have flown that much water through it, but because of impurities and the clog. You will begin to notice when they start clogging up, just like and a sand filter from the water plant in town. They will notice when they need to backflow those and hammer them to reset that filter, because the amount of impurities and stuff in the water is compressing it, makes it almost impossible to push through.
Okay.
That is why you got to have at least minimum of 10 psi to get through this.
Okay.
Maximum, just because of the container itself, is a maximum of 125 psi.
So if you had, say, like 8 psi, you're not getting through
you're
this
not
filter.
pushing through this.
So it's just going to stop.
Yeah, it'll be like shutting a valve.
It'd be like turning the valve off. Well, I got you.
This is actually where it's pulling out the turbidity and everything else. The discoloration in the water is slightly because it's coming through here.
Mm-hmm.
The fineness that's coming through here is really, really fine, and that's where the third filter comes in.
Okay.
Which
we have not installed yet.
I accidentally screwed up and bust the housing, so
we got to replace it.
I got to replace the housing.
Now,
which that housing, when you really talk about it, so that's a 0.5. We're doing a 0.1 or smaller.
Okay.
The impurities that are coming out of there are that membrane is so small, you're not seeing them impurities. You will see the discoloration in it, but they're not visible to naked eye.
Okay.
That is why that water looks a little yellowish. Part of that is, on the initial setup of this, when we first ran this system, I have the chlorine set high because I'm doing a burnout. I am shoving as much chlorine through the system as possible to disinfect all the lines and to make sure I have a chlorine residual sitting in the tank.
Okay.
Because as a water operator, you're required to have a chlorine residual in your line you're kicking out of your plant. We're not a commercial water system.
So this is basically a downscaled version of commercial water system.
This is actually, yes. Basically, from what I did for a living several years ago, this is a very simplified version of what the water plant we were running.
Okay.
A lot smaller, instead of where this system is a 1 to 3 gallon, up to 6 gallon a minute system. Where I'm used to, where it was we were kicking out 1 million an hour. So
that's a lot of water.
Kind of shows you the concept. It's a lot simplified system.
Okay.
But same kind of concept.
What is this thing?
This big metal tank is actually the bladder.
Now the bladder, that is the same thing that is on
the tank.
On that green pump here, right?
Yes.
So that green tank is the same thing as this tank.
Yes.
Okay.
The eventually the water pump will actually sit right here.
Okay.
It'll pull in out of that tank, that concrete tank, into here. It'll then be hooked onto this, also be a T-valve here, so where it's pushing water into this tank.
Mm-hmm.
Same kind of concept that's on the ram pump.
Okay.
Or on the water towers that you see in town.
Like those great big ones where it says blah, blah, blah.
Yeah. It's the same kind of concept. Instead of using gravity on them big water towers, I'm not putting a 40-foot structure up to build me my 20 PSI that I want.
Okay, so what's the benefit to the bigger tank as opposed to this little green tank here?
The bigger tank, literally it's just volume. Due to the fact we are feeding through a 2-inch line coming out of this facility.
So
feed everything.
That's going to be the 2-inch line that feeds these 2 future cabins for the Dude Ranch type agro-tourism thing, right?
Yeah.
Okay.
And then let alone everything else that we want to do. swimming pool and everything else.
Yeah, it never hurts to have clean water.
Yeah, and one thing we discovered a long time ago, water's always been kind of what's held us back.
And that's mainly because of how to pump it up here.
Yeah, and when you have to go haul water, that's okay. That's a 1,500-gallon tank. That's a week. We filled that up last weekend, and we've already backed down to where we're at. In a week's time, we've sucked that much water out. We're catching back up. Usually that'll be about a week and a half or so, 2 weeks for us. But
and we'll get a shot of the plastic containers that we were using.
Yeah.
People will see the square ones and the big round green or blue ones. Those are used for potable water, right?
Yeah.
Okay.
The big purpose of this, because the amount of volume we're using, this will deliver more volume of water at the PSI that we're wanting to keep it between 60 and 30 PSI. 20 PSI is, by the state tells me that I got to have water in my water main at 20 PSI to meet state specs. Everything we've done here was designed to meet state specs or above state standards.
Okay.
Kind of like...
Now, you did say that we're putting another filter here, and if I'm not mistaken, you said this is
This is the last stage of the water treatment. This is a UV.
Okay, UV.
This will kill basically everything. This guarantees that there is nothing left alive that's going to make you sick. So if anything gets past my filters and my chlorine, these will actually kill everything. It's any bacteria that's left alive that might make us sick, it'll stop.
Okay.
It'll actually be inside the cabins.
So this is the last step before...
This is the last step right as it comes out of the tap.
As it comes out of this pump and everything, it'll go through this, or is it going to go through this and then through this?
No, this will be inside the cabins.
Okay, so each cabin will have one of these.
Yes.
In order to help with the water.
Yes.
Okay. And what are the lifespan of these parts that we're looking at here? Like the chlorine and the tank, and you mentioned that this tank here had like a couple of years on it.
Yeah.
But what about the chlorine and all of that and the filters?
Is something we have to check regularly. More we pump, the faster it eats through. The downside to an inline filter like this is, if you can see, there's no way to check to see how much chlorine you have in there. You literally have to put a mask on, shut your system down, and open it up and look.
Now, is there any plans to change that into one you can visibly look at instead of pop it open?
Yeah, probably down the line it will be.
Okay.
There's always a possibility. The idea of going chlorine gas is always one, but chlorine gas is the most deadly.
And it's very corrosive.
Yeah, it's very, very deadly, and let alone you got to have an entire facility just for it. So probably not going to do chlorine gas. Most people will use bleach.
Okay.
Downside, I've dumped bleach into systems before too. It's a quick disinfectant, it works. Problem is, bleach has a very short lifespan, and you got to keep it in a dark area, and it does not like heat. Every time you introduce it to heat, it starts becoming weaker. You start putting you put a bottle in the sun, it just got weaker. So that chlorine that you bought, that bleach or Clorox you bought from the grocery store, 90 days max, be able to be truly disinfecting. Anything over that, yeah, it'll kill stuff, but do you really want to take a chance of knowing what that percentage of, it's supposed to be most of your stuff in your store is about 3%, and I can get a hold of some stuff that's about 6 to 10%. A lot stouter.
Okay.
Problem is, it's at 90-day lifespan. How much am I going to go through in 90 days, and how much do I got to keep on stock? and it constantly falls
So
over.
this little thing here is basically making bleach on demand.
No.
Okay, so it's using this stuff here.
It uses a granular. That is the third type of chlorine that you have out there. That is actually chlorine right there.
So it's not the same as like a swimming pool.
Somewhat is. That's instead of the tablets or hockey pucks, that looks like little BBs.
Okay.
Basically, when it runs through, it's turning over really quick.
Okay.
The water's coming in and it's pushing up through all those, and it's kind of
So it's its own
bubbling.
agitator.
Yeah, it's agitating them all out before it comes out, and it falls down. There's actually an inner liner there. It's pushing it
so
up,
one side is
and it falls back down.
And I
down
apologize,
around, goes
YouTube. This is actually kind of a dangerous thing to open without the proper safety gear. So make sure you have a mask, a full face mask.
As you can see, mine's sitting out.
This has a hard plastic face.
Full face, right? Has special filters on there. And these filters, they will protect me for this. But I'm also not going inside a chlorine room. I do have...
so you don't need a full respirator system for this because it's kind of open.
Because of the open area, and chlorine is 2.5 times heavier in here, it's settling pretty quick. But the problem is, my head's right here. I'm going to get a full dose of it. And for someone that's been dosed with chlorine before as an operator, you don't want that because it hurts.
And this building has 2 doors, so we open them both, help get some airflow, but this is an extra step just in case, right?
Yeah, extra safe and safety, because the last thing I want is my wife to come home and find me dead because I got dosed with chlorine. It said, I've been dosed with chlorine. It's a long recovery back. It hurts.
All right, so anybody that wants to do a system like this, how much are we kind of looking at here?
You can run anywhere from, depending on what you're pulling out of your water. I tested my water coming out of that pond, so I know how much iron I have to remove, how much manganese I got to remove, how much fluoride I have to deal with, how much organics I have to with, manganese and everything else.
So you had the water tested.
I actually literally have not the information on how much of impurities and everything and metals I have in that water that I have to remove to get down to what is considered a safe drinking level by EPA and the state.
And by personal use, I mean, I don't want to be drinking manganese.
Yeah. We're pulling it out. We're once we get the other filter in and everything else. This is a 5-log removal system. We're pulling out 99.999% of all impurities and contaminants.
Right, and we're not even 100% complete on this.
Yeah, we're not even 100% complete yet. As I said, this whole thing was designed on the concept to be the most advanced water system in the state. That's what the whole UV is.
Okay, so this is 100% based on state-operated water plants.
Okay. As a Class 2 water operator, this is what I went to school for. This is what it was designed to do.
Okay.
The cost here, your big cost is going to be this bad boy here. It's a couple $100.
Okay.
No matter what. You can build them cheaper.
But it's easier to buy it, and you know it's quality.
And it's for the cost of the couple $100 I spent on this. I could build one. Yeah. Problem is, it's going to be a pain. And to the fact, they take room. This is all enclosed one. All I have to do is bust off 2 valves, put the new one in, put the valves back in, go. So literally, all I have to wait for is the ship back in.
Okay.
You build one, you said, as a water plant, you got to backflow them some because they start compacting down.
And that's putting pressure the opposite direction,
Yes.
correct?
You like we blew air back through it.
Okay.
That lifted the entire membranes back up.
And that kind of like putting it in a blender or
it's
something.
Like sand.
Okay.
You sit sand there in water and let it sit there, it starts compacting amongst itself. More you try to push down through it, the tighter it gets.
Okay.
The idea of pushing air is pushing air through the bottom. Air's going to rise.
I seen a guy on YouTube use liquid nitrogen or something of that nature in a swimming pool full of sand. And it was like really fluid. And it was really awesome because when you turn that air off, you're like got your arm stuck in there. It was the coolest thing. So it's basically the same thing as that. I got you.
We actually have a bigger one of these too.
Oh yes, I seen that. We'll get a quick snippet of that.
The original setup for this was actually going to be down to where the ram pump's going to be moved to. So it literally was gravity feeding off that pond through all this system, even through that.
But now with the ram pump, we can bring the whole system up here where it's easier to maintain.
So the upgrading of this is going to happen because now we're actually at a faster flow rate than what we were down there. We were right at the minimum flow rate down there. Just because the water pressure off of the thing, that was where it was designed or told where I needed to be at.
Gotcha.
Because that was at my minimum water pressure to get me my PSI that I needed to get through the filters.
But we'll get a picture or a quick video of the
total
other
cost
tank.
of into this, we are into a couple grand.
Okay. So for say $3,500, you can do a system like this for an off-grid system and do a really quality job. Is that right?
Yeah, about anywhere from 25 to 6,000, depending on what you're truly wanting. I literally have put one in before for about 10 grand.
That's a big one.
They had very unique problems out of their water, so we had to address it, and it started running into cost.
Okay.
A lot of it comes down to is what you're having to pull out of your water. The company that we got this whole system. Basically, we sent them and said, "Hey, this is what we have coming out of our water. This is what we need." They put it together and shipped it to me, and that's what is nice about. You can find companies that do that.
Okay. Do you remember the company so we can send a link? Or
I do not remember. I'd have to look it up.
We will try to do that. That way we can link to them because apparently they did a really nice job of sending all the stuff out to us.
I want to say it was Aqua, but I'm not for sure. I'd actually have to do. I know they do business with Colgan and everything. That's where we get all of our filters and stuff from.
Okay.
So, if you do a system, as you said, there are 3 kinds of chlorine. There's the gas, which I do not recommend anyone to do because you've got to have that mass right there. It will not save you. You'll still die in a heartbeat. You got to have really good filters on it because it will.
So if somebody else was designed, they need one that they can visibly inspect without opening.
If you do it, either go with granular chlorine like we are, or you go with liquid, which is aka bleach. Is the best way to say. Bleach by far is your safest chlorine out there. It's also your weakest chlorine. As I said, most industrial cleaner 6 to 10% on if you can find it. Normally, the stuff you buy out of the grocery store is probably closer to 3% actual chlorine.
So what's the percentage that this one's making?
This chlorine coming out of granular. If I remember right, this one is 73% with 27% added. It said, and I can smell the chlorine right there through a plastic bag.
Yeah. I can't wait till they have smell-o-vision.
As I said, best case, this stuff does not really like sunlight. this is kind of almost too much of a sun for it. It needs to actually be inside a deal. We kind of brought it over. I brought it over yesterday because I need to actually go into here later to check the chlorine.
Okay.
And we burnt through it pretty heavily the other day when I burned it.
Right,
So
we got to turn the pump back on so we can fill the water back up.
Yeah.
And is that filter, I remember that one being a lot wider. Is
Yeah.
it going to be okay?
Yeah.
Okay. What's the lifespan of the filters and stuff usually, depending?
It all depends. There's no set date on how long they last. It's all a formula based off water flow, your impurities, and
so once you know your impurities, your averages, and how much silt you're pushing, you'll have a good idea.
You can actually figure out by how much flow rate you're having coming out there. That is your biggest determination. If you're wanting a lot more, you can change your filters every week if you want, or every day if you want. If you just don't care, you'll have your maximum flow of water at all times. The dirtier the filters get, the slower your water goes.
Okay.
Same kind of concept of anything. You're screening for an inlet pipe. If you put a bunch of leaves on top of it, you probably ain't gonna get a lot of water going through your pipe. If you remove all them leaves, it's probably gonna go really fast. Same kind of concept. The dirtier that they get, the slower it gets, and that's kind of your big deal. You can run it to where there's literally no water flow through these, which I have seen happen before.
But it's still going to do its job.
It'll still do its stuff.
Okay.
You can literally stop the entire system off that filter right there because it gets clogged to the point where, like an air filter, there ain't no air going through it. It'll stop your vehicle.
So unless you know the impurities, the amount of organics and that kind of thing in your water, you're not really going to have a good idea of the formula. Yeah. But we'll try to link the formula to how you would figure this out. But
a lot of it is just depending on your flow. The best way to do it is just figure, okay, I want X amount of water flowing through there. Okay, you look at your inlet line to coming into your house, like, okay, I'm not getting enough pressure. I don't want. First place to start, go check your filters.
Okay.
Because like this, that was a white filter and that was a white filter.
Right. Now I remember installing both of these when we turned this thing on.
It said, if I was going to actually be running a little bit heavier, I would probably put a sediment filter, another one down there where we can actually inject our bleach into it quicker. Just to kind of help stabilize that stuff and kind of pull out all your sediments and make everything last longer.
Okay.
The downside is if you use bleach down there, because bleach and granular, just because they're chlorine, there are two different kinds of chlorine, it will make an explosion.
So that's something you have to take into consideration.
You have to take into consideration too. Just don't go out and add a granular and a bleach together. It does not have a great concept. It does not end well.
Well, since you took and went to school for all of this, in future videos, we'll give some detailed information on where all these parts are coming from. We'll try to link that, and we'll show how this whole entire system gets completely updated. We will go take a quick video of this other tank and get it posted probably as an addition to this one. But we're going to need to turn the pump on here in a little while because we are kind of running out of water. So more updates to come, and remember, like, subscribe, click the bell.
Yeah. Sorry, I don't explain stuff to greatest guys at work tell me that too all the time as I'm telling them to do stuff. So I'll try to work
long-winded, even though it's long-winded, I hope that anybody can actually get an idea of what they need to do with one of these kind of systems for off-grid.
Yeah, and if you have any questions to ask, I'll be more than willing to share the information that I do know.
Wonderful.
I'll try to walk through what I can to you the best I can.
Or we'll just create a video and try to explain it the best we can. Gotcha. All right, well, YouTube, you guys have yourself a pleasant day.
See y'all.
Okay, so here's the other tank. As you can see, it is much bigger. and it is much taller. As you can see, he's like 6'2",
I'm 6'5", 6'6".
6'5", 6'6". This is a much bigger tank.
Yeah, and you said we had a 3/4 inch valve going in. This one's, or a 3/4 inch valve going out of it for drain. Right there's a 1.25 inch.
So
yeah, it gives you an idea how big of a
and this
line
will help
coming in.
maintain some water pressure in the system. Is that right?
Yeah.
Okay.
Or not water pressure. No, not really.
The flow.
This allows the chlorine to react more.
Okay.
It gives it more time for the chlorine to mix and actually do its job and disinfect. So a lot of your impurities get removed better instead of just being pushed onto that next filter. It will be pulled out quicker, so that next filter can last longer.
So we're going to be installing this in place of the other one. That'll be a future video when we do this upgrade. So stay tuned with us, and we'll keep you updated as we do things.